Okay, welcome back. So in this video, okay, we will discuss how we're going to make use of the general term, okay, the formula you can see over here on the screen, okay, to help us solve some of the more, how would I say, advanced questions in binomial theorem. Okay, so the lesson objective is very simple. Just want to highlight this term over here. If the question asks for the term independent of x, the question is simply asking you to find the coefficient of x to the power of 0. Okay, so in layman terms, just find the number in front of the term x power 0. Okay, and sometimes the question might ask you to find the coefficient of x squared, for example, okay, or x to the power of 5, for example. Okay, so in the next few examples, it will just demystify this for you. Okay, so just stare at this red formula over here. This is very important. This is what we call the general term. Okay, so we're going to learn how to make use of the general term. Okay, so as per usual, I'm just going to leave it at the top of the screen to help you see better. So let's look at this example. Find the term independent of x in the expansion of, okay, this chunk of numbers you see over here. So what I'm going to do over here is to first identify my terms. Okay, so as you can see, okay, once again, if you have forgotten, binomial expansion typically looks like this: a plus b to the power of n. So if you just identify, in this case, my a is 1 over 2x squared, my b is negative x, and my n is 9. Okay, so first I write out the general term. Okay, so the general term, okay, as given from the formula above, tr plus 1 will be equals to n, okay, which is 9 in this case, choose r, a, which is 1 over 2x squared to the power of n minus r, so 9 minus r, and a b, which is negative x to the power of r. Okay, and since I want to find the coefficient, of x power 0, okay, what I'm going to do here is to first simplify, okay, the expression that you see over here. Okay, so yeah, here goes. Okay, so I'm just going to simplify this first. So 9 choose r. The simplification process can be quite tough at times. Okay, so I'm going to show you slowly. Okay, the power 9 minus r will go to the half, as well as the 1 over x squared. And 1 over x squared, as you can see, can be expressed in the form x to the power of negative 2. Okay, this is one of your laws of indices. Okay, and just going to carry on from here. So the numbers, I'm just going to leave it over there. For this, okay, for this x, I will just multiply in. So negative 2 times 9, negative 18 plus 2r. Okay, over here, the term at the back, it might get a little tricky for you. So what I'm going to do, I'm going to break negative x out into negative 1, okay, power r, and x power r. Okay, finally, if I were to just do one last line of simplification, so this will go like that. Sorry, minus 1 comes here, minus 1, power r, okay, x to the power of negative 18, 2r plus r will give me 3r. Okay, so if I want x to the power of 0, okay, this will mean, okay, I will sort of equate this with x to the power of negative 18 plus 3r. Okay, and if I solve for this, okay, my r will just be 6. Okay, and so the coefficient that we want, okay, coming back to here, the coefficient of x to the power of 0 will just be 9 choose 6, because I've just substituted r equals to 6 into this expression over here, into this expression. So 9 choose 6, half, 9 minus 6, okay, minus 1, power 6. Okay, and if I were to just simplify this, I can use a calculator to help me. So 9 choose 6 is just 84. Okay, 84 over here, 84, half to the power of 3. Okay, and negative 1 to the power of 6 is just 1. Okay, if I simplify this, so 84 here the coefficient that I want is just 10.5. Okay, so the term independent of x is 10.5. Okay, or you can write 10.5 to the power of 10.5 times x to the power of 0. Okay, but that's not required. That's kind of redundant. Okay, so we'll just stop here. Okay, one more example. Find the coefficient of x power 3 and x power 6 in this expansion. So once again, I'm going to identify my a. My a is 1. My b is negative 3x. My n is 8. Okay, so first write out the general term once again. So general term, so tr plus 1, okay, is equals to n choose r, so 8 choose r. A, in this case a is 1 to the power of 8 minus r. Okay, and b is negative 3x to the power of r. Okay, take note that 1 to the power of anything will still be 1. So I can easily simplify this to become 8 choose r. Okay, this term is gone. So negative 3 to the power of r, x to the power of r. Okay, now if you're wondering why, I went to break this up, okay, it's because if I want the coefficient of x, okay, so if I want the coefficient of x power 3, okay, what do you think my r should be? My r should just be 3. Okay, so if r is 3, okay, yeah, if r is 3, okay, then the coefficient will just be, so the term will be what? T 3 plus 1, okay, I sub my r over here, which is term 4, and this will just give me 8 choose 3, negative 3 to the power of 3, x to the power of 3. Okay, simplify this using your calculator. So this will give you negative 1512 x power 3. Okay, so if I want the coefficient of x to the power of 6, okay, in this case my r should be 6. Okay, so I want to have 6 over here. Okay, so the term will be the 6 plus 1 term, which is the 7th term. Okay, and it's just 8 choose 6, negative 3 to the power of 6, x to the power of 6. Okay, and once again, I'm going to use my calculator to help me. 8 choose 6. Okay, punching this in your calculator, you get 28. Okay, negative 3 to the power of 6 will be 729, x power 6. Okay, and finally, you punch your calculator, you will just get 20412. What a huge number. 20412 x to the power of 6. Okay, and that's it for this example. Okay, so just to summarize, in this part of the chapter, we want to make use of the general term, okay, to help us find particular, more complex forms of binomial expansion. Okay, so for example, we want the term independent of x, and for example, we want the coefficient of x to the power of something. Okay, so once again, take note of this formula over here. I strongly recommend you copy this down, and I also want to highlight that once again, the term independent of x refers to the coefficient of x power 0. Okay, this is very important. Okay, see you for now.